Hey everyone, in this video we'll be exploring SageMaker JumpStart, which is a feature within Amazon SageMaker, and if you would like to learn more about what SageMaker is, please refer to my previous video linked in the comments. But what we'll look at today specifically is how can we easily deploy LLMs for inference using SageMaker JumpStart. And before we even get into that, just a bit of an agenda or an outline here is we'll look into what is model deployment first and what is hosting and inference. What do I specifically mean when I'm talking about that, and we'll whiteboard that out. And then we'll talk specifically about what SageMaker JumpStart is, how does it really simplify this process, and then how can we actually interact with it. And then of course I would like to get pretty hands-on with it directly, and it's not a very verbose code sample, but we'll link the GitHub down below as well. And what we'll do is we'll take Llama3 8B, one of the more popular LLMs out there, and we'll showcase how you can deploy directly via JumpStart itself. That being said, let me share my whiteboard really quickly so that we can kind of highlight the first step in all of this. So right here for SageMaker JumpStart, before we even get into that, what we'd like to talk about is what is model deployment slash hosting. And I know I've spoken a lot about the ML lifecycle and how there's many different components within this. I think I accidentally erased some stuff there. But how there's many different components within the ML lifecycle. Where ML is really realized is model deployment and hosting. And what this feature really is it's the practice of exposing your model as an API. So at the end of the day, when we do have a trained model, or whether it's pre-trained in this case, we take the pre-trained Llama3 model and deploy it, we need a way of exposing it as an API for us to be able to integrate into our applications. Let's say you have a chatbot UI that you've built. You need a way to invoke that Llama model or whatever LLM that you're essentially working with. And for model deployment and hosting, there's essentially two different factors that you often have to think about that will come into play. One is hardware, and then two is a model server. And I'm going to put the word container in parentheses here, and I'll explain what I mean by that in a second. So the hardware that's necessary to host these models is very crucial. Because if you think about these LLMs, right, they're scaling up to tens of gigabytes worth of size. And you basically need the compute and memory to be able to host these. And this is why you can't really pull down, for example, a Llama model onto your local PC without it really blowing up, unless you have some sort of supercomputer. But you need the compute and memory, and you specifically will hear you need GPU-based instances, right? To be able to host models of this capacity and size, essentially. And that's where really the cloud becomes popular, because you can access these GPUs from there with services such as SageMaker or EC2 or EKS. But the first component, right, for any deployment or hosting is identifying the hardware that your model needs. So if I have an 80 gigs model, what is the instance type or the machine that I need to be able to host this? That's challenge number one, right? Challenge number two is, once you do have the compute, that doesn't necessarily mean the problem's solved. You need an intelligent model server, or you can almost think of it as an orchestrator that knows how to do a few things. Load your model into the available memory. And for instance, in a real world setting, right, you're going to have many different concurrent requests. And you need a server, very similar to the concept of a web server in a traditional kind of software engineering world, that will understand how to process these requests and send them to and utilize your hardware to properly process these requests. And that's essentially what a model server does, right? Is think of it almost as the protocol between your client and the hardware that you have allocated behind the endpoint itself, or behind your model that you're working with. So anything that comes with the model management and interacting with the hardware as your requests are coming in, that's where this model server is kind of that intelligent kind of language to interact with this hardware. So you can have all the compute in the world, but if you don't have a powerful model serving stack that essentially knows how to handle the requests, handle the model, and essentially use the compute and memory that you have provided for that model, then you're not going to have good performance. And popular model servers, examples of these, right, include Triton Inference Server, which is by NVIDIA. And this comes with the ability to host many different models of different frameworks. And then you might also have, there's TorchServe, which is another popular one. And then within AWS, there's something known as DGL serving, which is used for LLM deployment. And another one is known as TGI, Text Generation Inference by Hugging Face. These are LLM specific model servers. So these are very much tailored to handle larger models, and I think Torch Server and Triton also have some capabilities there, but we'll dive into that later. But the main key here, right, is this is a lot to understand. So there's a lot of work here when it comes to especially understanding the container or the model serving engine, because you might need to tune it. You might need to say spawn this many threads per model, or use this in memory, or keep this unloaded from memory. And that becomes really challenging, especially if you're not a straight out ML engineer or you don't have experience in any of these different facets. And it's also challenging just understanding what's the right hardware for me to achieve optimal performance. As an end user, I kind of just want to come in and I want the ideal configuration set for me, the hardware chosen, the model server chosen, and I want to just deploy that simply. And that's really where the idea of something like SageMaker JumpStart comes into play, where essentially with this feature, this abstracts out the hardware and container layer. And by the way, to clarify here, when I say container, right, this just essentially fronts the model serving engine. It provides the runtime environment to be able to execute these different models. So if you're using TorchServe as the model serving engine, what SageMaker does is it provides a managed container specifically for TorchServe, or you could optionally bring your own for that real-time inference. And that's, once again, just kind of think of it as the runtime environment that's implementing that model server that you're choosing. But let's say you don't want to choose a model server, you don't want to choose a container. That's where SageMaker JumpStart says, depending on the model that we're dealing with, let's say, for example, it's Llama, as we're going to use in this case, we've already identified the optimal configuration in regards to both of these aspects when it comes to the hardware and the container. We're not going to tell you to use Triton, TGI, whatever it is, right? We've already selected a container for you, and we've already selected the ideal hardware type behind it, and ran some preliminary benchmarks right here. Had a word fumble there. But what we can simply do, right, is through SageMaker JumpStart, select this model ID, and then say, give me this optimal configuration, and deploy it for me on a SageMaker endpoint. And I know this seems very similar to Bedrock, which is one of the videos we talked about earlier, but the key difference here is this is not serverless. In Bedrock, when you provide the model ID, you're still not seeing any of the hardware behind it. In this approach, when you're deploying the model, it still deploys on a instance, which is the compute or machine that you're selecting behind it. It's just that this is pre-selected for you ahead of time. And you can optionally, right, if you have the ML engineering knowledge, or you know that maybe this instance gives me better performance or what I'm looking for, you can change this. This is not set in stone. So there's that flexibility of, if you do know the hardware that you want, you can select it. And that applies to the second parameter we talked about too. Let's say that you don't want to use SageMaker JumpStart and you want to just specify the hardware yourself, your model serving stack yourself. You might be very experienced with one of these and have written your own tests. You can simply bring that to SageMaker too, and that's something we'll cover in future videos, but you're not forced to use JumpStart to deploy any of this. If you have knowledge of the hardware and the serving layer stack that you want to use, you can easily bring that yourself and deploy it. This is just purely an abstraction layer above. And very clearly, it's also not serverless. This is real-time inference. That's the official term within SageMaker. And within real-time inference, you always have an instance or a compute machine backed behind it, no matter what. And now that that's kind of been clarified there in terms of what SageMaker JumpStart is itself, let's hop over to the UI really quickly to understand how we can interact with this first and foremost. So here I'm in my landing page for Amazon SageMaker. Where I'm going to work is in SageMaker Studio, which is essentially an IDE for ML development. You can work with traditional ML workloads there too, or in this case, you can work directly with SageMaker or whatever it is. You also see that JumpStart, there's a tab here to toggle the different models that are available, but we'll just simply go into the UI and understand how we can interact with it here. So if I land in Studio, you'll see that I also have JumpStart here. So option one for how you can interact with this, right, is through using the UI itself. So you'll see here, there's the different model providers that we're talking about, and these are the companies essentially that are exposing their models for you. And what we'll do is we'll take Llama3 8B as the sample here. It's a pretty popular OSS model, and you'll see all the different kind of models that are accessible and available for you essentially. So you'll see that there's the Llama family here, and what we can do is we can grab the model of interest. So I'm interested in Meta Llama3 8B right here. And I can click on this, and it's very important to take a look here, because if you scroll down, you can see in this model card, essentially, there's all the different information in terms of how you can use this. So there's the licensing, which you should take a look at, and then also model architecture for those who are interested in the data science side of things, and very importantly, the context length in terms of the input that we can pass in. And then also, you'll see any preliminary tests and benchmarks that were done. So that's one of the other kind of value props of using JumpStart, because this ideal configuration was essentially decided ahead of time for you, or pre-suggested by AWS. And like I said, you're not constrained to just using that deployment specs. You can adjust it if you have that knowledge or you have a different kind of configuration you want to work with. But that's a bit of the simplicity to kind of use it with. Here we'll see there's an associated notebook, which provides the model ID that you can essentially use and how you can deploy it. And you'll see that there's a payload, right, that you can essentially retrieve. That is a sample payload for how Llama3 expects it, and we'll walk through all this in our own notebook in a second. But you can take this and use this as a bit of a boilerplate if you want to experiment with it, essentially. You can say, this is my model ID, this is what I essentially want to walk through, and this is exactly what I'm dealing with. And here, if we go here, right, before we go into the example notebook itself, there's options to also train, optimize, and evaluate. We'll dive into these a little more in future videos, but what training does is it also, once again, similar to deployment, abstracts out a lot of the container level details and also the fine-tuning techniques such as QLoRa, and it wraps around it and does it for you ahead of time. Optimize here is if you want to get to more advanced inference kind of performance or understanding, you can simply use techniques such as speculative decoding and quantization that are enabled through SageMaker JumpStart by default. And evaluation is on the data science angle. So if you want to evaluate your model across like different tasks, such as summarization or Q&A, there's some built-in evaluation tools that are existing within this. And now here, if I click this deploy tab, right, if you would just like to work with this through the UI, you can accept the licensing agreement. You can see that there's a default instance type that's been chosen. And for the model, you can see there's the different configuration options that you can pick. So depending on whatever your SLAs, your throughput or latency requirements are, you can essentially select the different kind of configuration that makes sense for you in terms of your performance. And also within this, right, and this is once again for those who are a little more advanced and want to understand the container settings, you can see the different container level parameters that we've set here. And you can simply hit the deploy button to deploy this into a SageMaker endpoint. Now, many of us, though, will end up here programmatically, right? And if I take a look into this, essentially, this notebook, and we have this linked on GitHub as well for you to access, what we'll see here is that we can work with SageMaker JumpStart via two SDKs. There's Boto3, and this is a documentation that I'll also link down below. This is the general AWS Python SDK, and you can work with any AWS service through it. And in this case, right, you can use the API calls that are listed here to specify that JumpStart model ID and work with it. Optionally, though, there's a higher level SDK known as the SageMaker Python SDK, which is what we'll use in this example. And this higher level Python SDK essentially wraps around these lower level API calls, essentially, and it makes it simple. So you essentially, these are a little more verbose in nature, and they have their place, especially when you have a little more of a complicated deployment case. But if you have a simpler use case, such as using just a JumpStart model ID directly, you can simply use the SageMaker Python SDK. Now, if I go here, right, what I'll see is, initially I installed this SageMaker Python SDK, the latest version, to just be safe. And then what I can do is, I can either grab the model ID from that UI as we were looking at in Studio itself, or I'll use some of the utility methods that are provided by the SageMaker Python SDK to list the different model IDs. So my model family right here is Llama3. I'm going to list the different model constructs that I'm dealing with, essentially. These are the different Llama3 model families that are available at this time. And I take this essentially, and I say here, this is the model ID that I want. I don't specify any instance level parameters or details such as the deployment specs. I simply say this is the model ID I'm working with. Can you deploy this? And I'll accept you as true for the licensing right there. By default, this is a G5 12x large as we saw in our UI, but you can also adjust this, right? So if I want to adjust this and pass in a parameter such as instance type, you'll notice it auto-populates there, and you can replace this, for example, with maybe a MLG5 24x large if that's what you would like. So all these options are existing within this, but what we'll do is we'll go with the default kind of configuration here. This then deploys a JumpStart endpoint, and this might take some time because what's essentially happening here is the model artifacts are being downloaded because they're prepackaged for you essentially. So this is the model data, and the container is getting chosen for you. And then this then creates a persistent REST endpoint for you to invoke. And you can see this in the UI right here. If you go to Inference, Endpoints, and you see this right here, this endpoint name right here. This is our persistent REST endpoint that's been created for us. And you can see it's an API that you can simply invoke. So right here, you'll see this public API is accessible. You can also back it with a VPC if needed. And then you'll see in these model details, right, that all of this has been pre-populated for us. So if I go into settings and if I click the model name here, different types of information, such as the model data and the image to use, have already been pre-packaged and made ready for us. Traditionally, if you brought your own container or your own model data, right, you kind of have to specify all this on your own via the API calls. But JumpStart takes care of that process and creates that endpoint for you. And right here, you can see successfully this endpoint's been created. And if we go here, we can run a sample inference. So inference is passing in the API request, and then we can get the output there essentially. So my query is, what is AWS? I structured this in the format that Llama expects. So this varies depending on the model provider that you're using. We can see what this payload looks like then. And what I do then is I send in a sample API request right here with the payload and any licensing right there. And I'll see the generated text here in terms of it. So that's a quick sample of how you can invoke it. And if you would like to test farther right, I encourage you to just go to this endpoints tab here, and you can essentially kind of monitor your requests and your utilization as well. So if you pass in some more like invocations and you want to see how it's performing with the hardware that's behind it, right, you can pass that in, monitor the hardware metrics, things of that sort. And we'll dive into everything that SageMaker provides by default here a little more later. But the crucial part is just understanding how we can get started with JumpStart to easily deploy these LLMs. And most importantly, make sure to do this as well. This deletes the endpoint resource right there. If you don't delete this, you'll basically get billed by the hour for the instance type and count that you have behind it. So this cleans up the resources there. But yeah, I think that's a good conclusion on this for now. And I will follow up, like I said, on how you can maybe bring your own serving stack, explain a little more about what SageMaker Inference is, what exactly was that endpoint, how does everything come together there. But I hope this was a useful introduction to what SageMaker JumpStart itself is. And it's a very quick way of really getting started with deploying a endpoint on persistent hardware for real-time inference for really quick latency here. And I think that's it for now, but thank you for tuning in as always. It would mean a lot if you could like and subscribe, and we'll be back with more as always. Thank you.